Hello everyone, welcome to Almighty Tricks. So in today's video, we'll be understanding about how we can delete a node from a linked list. So in my previous video, we have already discussed about why linked list is required and what should be the structure of the linked list and how we can traverse the linked list. Okay, so in the last video also I have already discussed about how we can insert a node in the linked list. So I'll suggest you to watch all this video first, then come to this video. Okay, so in the last video, in the insertion of a node in a linked list, so there are three things, right? We can insert in the front, and we can insert it in the end, and at a specific position, right? So similarly, in the deletion in the case of deletion also, so we can delete in three points, like at the front we can delete, we can delete at end, and we can delete at a specific position. Okay. Okay. Now let's understand one by one. So let's. This is my linked list. So this is a linked list, and currently it is pointing. This is the head. Okay. So we want to delete from the front. It means what? We need to delete this node. We need to delete this node. So how we can do this? So so currently this is the head. So if we make this node as a head, then it will automatically delete, right? So let's understand. So we can do like head equals to head dot next. So currently this head is pointing to this. Okay, so we want to make this node as a head. So what we can do? So head equals to head dot next means heads next. Okay, so this has become head now. Okay, so now this node is deleted. So the time complexity here will be order of 1. Okay, this is the linked list I have. So we need to delete from the end. Okay, so end means what? So we need to delete this node, right? We need to delete this node. So if you see, so this node is currently pointing to null. Okay, so we need to delete, this is the end, right? So we need to delete this one. So what do we need to do? So this is the head initially. So as for our last videos, we should have one backup for the head, right? So I'll be creating one backup, let's say temp equal to head. Otherwise this head will lost. Okay, so what we'll do, we'll go each and every node. Okay, at the end, till the end we'll go, and when we, so this node we need to delete, right? So when we come to this node, so we'll do what? This node's next will point to null, right? So automatically it will delete. So how can we get this node? So let's understand. Let me write the code, then I'll explain. So I'll have the while loop, and temp each temp dot next is not equals to null, and temp dot next next. Once let me write this code, then I'll explain. Then temp is equal to temp dot next. Okay, then finally temp dot next will be null. So let's understand this code linked list. So this is my linked list. Okay, so currently this is my head or temp. Okay, so I'll check. So what I am checking? So I am checking temp dot next. Temp dot next is not equals to null. Temp dot next is not equals to null. Okay, so temps next is not equals to null. Temps next is not equals to null. So it will change the head, right? So now this temp will come here. Okay, now again I'll check temp dot next is not equals to null. Temp dot next dot next is not equals to null, right? So it will again move. Okay, now again temp dot next is not equals to null. Temp dot next is equals to null, so it will not execute this one, so it will directly come here. Okay, now if you see, we need to delete this one, we need to delete this node. Now we are here. Okay, so what I can do, temps next. So currently temps next is this one, so which we need to delete. So temps next, if we make it as null, then it will delete, right? So that's what I have written here. Temp dot next is equals to null. Okay, hope you understood this one. The time complexity will be order of n, so we need to go through each and every node till the end, right? That's why it is order of n. Let's say a position is given 4. Okay, and this is my linked list. This is my linked list. Okay, let me put the number also, 1 2 3 4 5 and 6. So we need to delete the specific position, that is 4, position 4. So we need to delete this node, right? So what we need to do, we need to, this is the 3 and this is the 4 and this is 5, fifth node, right? So we need to delete this fourth node. So what we'll do, 3's next 3's next should point to 5, right? Then this node will automatically delete. Let's understand how we can write this code. So first of all, I need to have the backup. Okay, so node temp is equal to head. Okay, I need to have one counter to track the temp. So what we'll do, we'll traverse till here. Then when we are here, just we need to make this connection to this connection. So we need to traverse, right? We need to track the number, so that's what we need to have the counter. Let's say initially 1. Okay, now we can have one while loop. So first of all, we'll check if temp is not equals to null and counter is not equals to position minus 1. We need to come till this point, right? So position minus 1. Okay, now we need to, if it is satisfying, then counter plus plus. I'll dry run this code. Counter plus plus, then temp will be temp dot next. Okay, now I'll check if temp dot next not equals to null and temp dot next is not equals to null. Okay, then what I'll do, I need to have one node, backup. Let's say here I'll save the temp dot next element. Then finally what I'll do, temp dot next is equal to backup. Okay, so let's dry run this code. So let's say this is my linked list. Okay, this is my linked list and position is given, it's 4. So this, so 1 2 3 4 5 6. So this node I need to delete. Okay, let's create some variable. So I have created this counter, right? Let me create counter here. So initially it is 1 and initially it is temp, right? So what I am checking, temp is not equals to null and counter is not equals to position minus 1. Position minus 1 means what, 3. So currently it is 1 and temp is not equals to null, so it will move here. Similarly, temp is not equals to null and this will increment because we are incrementing this one, right? So it will increment. Counter is not equals to position minus 1. Okay, so temp currently here, again it will increment 3. and it will move to here. Okay, temp. Now temp is not equal to null, but position is 3. Position is 3 and counter is 3. So it will not execute this. It will not execute this now. So it will come here. Okay, so I'll come to this condition later. Okay, so we need to delete this one. So currently this temp is here. We need to delete this one. So what I am doing, I am storing this part. I'm storing this part in the backup. Okay, so this is backup, let's say. Okay, if I am deleting this one, it will lost, right? We will lose this data. So I am storing this in a node. Okay, now what I am doing, temps next. So currently temps next is pointing to this. Okay, now what I need to do, this next should be point to this. Okay, so that's why I am doing temp dot next is equal to backup, right? So it is automatically deleting. So now come to this point, this condition. Let's say position is given. Let's say position is given 6. So at the 6th position we need to delete. It means what? From the end. Okay. So here if you see I'm doing temp dot next dot next. So this temps next is the null and temp dot next is not there. Okay. So it will give null pointer exception, right? So to overcome this scenario we are using this condition. Okay, hope you understood this one. The time complexity will be in worst case it will be order of n. Okay, because let's say position is given 6, so we need to go through the nodes till the end, right? So in the worst case, okay, worst case. In the best case it will be order of 1. Let's say position is given 1. At first position we need to delete. It means what? We need to delete this one. So from the head we need to delete. So this is order of 1. So it is the best. This is the best case order of 1. This is the worst case order of n. Okay. So hope you understood this linked list series. Thank you for watching this video.